Oh, settle down there, Vanillas. All right. Congratulations on making it to Unit 9. That means we successfully made it through the previous 8 units, so well done. This is going to be the final unit of this school year. And this unit is talking about, as you can see, angles and angle relationships. Today we're going to be talking about angles and parallel lines, perpendicular lines, things like that. So let's get started. Most of you are familiar with lines before and angles. An angle is just where two lines intersect or where they meet. They form an angle. And before we start anything about it, we need to talk about how to write an angle, how to write it down with a pencil on your paper. And there's 2 different ways you can do it. Here we see an intersection of 3 different line segments, and it creates 6 angles. Angle A goes basically from there to there. Looks like it might be 90 degrees or very close to it. And we're going to write it down simply by putting a little angle sign and then the letter A. So if you're writing it on your paper, it would look like a little angle sign and then A, and that represents this angle right here between this line and this line. Angle E is between this line and this line, so it is this angle right here. So if you wanted to write angle E from this diagram, you'd put the little angle sign and then E. Angle C, if you're not sure where that is, that would be from this line to the point where it intersects and then out this way, so it would be this space from there to there. Again, you would write it as angle, little angle sign, and C. So it looks kind of like an L, but it's actually a little miniature angle, and that just represents the angle. So that's one way that you can write a sign for an angle. So it could be angle B, angle C, etc. Now you might also see line segments with letters on the end of each line, which represents, in this case, C is the end of this line here, and D is the other end of it. And you can see over here, we've got an angle sign, and then the letters A, G, D. So this requires a little bit of work for you. You have to start out at A, go to G, which is in the middle here, and then over to D. So angle AGD, this one here, is that angle that we just made. It's from A to G into D, and it creates this angle right here. So that would be angle AGD, right there. Angle BGF, again, you would start at B, which is up here, go to G, which is in the middle, and then to F, which is down here. So this angle BGF would represent from here all the way around to there. Again, that's angle BGF. And the last one here is angle EGD. Start at E, which is right here, go to G, and then go to D. And you create an angle which goes from there to there. So this is angle, with the little angle sign, EGD. So you just follow the points and go from spot to spot, and that's basically the two different ways that you can write down an angle. If there's a letter right in the corner, you just write down the angle sign and then the corner letter that matches, corresponds. And if it's not, if there's not one, you can create angles by just picking 3 spots and putting them down in order. So if you wanted to, let's get rid of these, and say you wanted to, while you're sitting there right now, what would you write down for this angle here? So from here all the way down to here. Hopefully you're thinking to yourself, well, that is angle A, G, D. No, it's not D, it's an E. My bad. A, G, E. Or maybe you went the other way. Maybe you went backward. Maybe you went E to G to A. Either way is fine. Okay, moving on. Let's look at something called a complementary angle. A complementary angle, as it says here, is any 2 angles that add up to be 90 degrees, which is a right angle. So here's a right angle. It's 90 degrees. And these 2 angles, 40 and 50, add up to 90, and they make a complete perfect right angle. Those angles are said to be complementary. So 40 degrees, this is a degree sign, most of you know that, and 50 degrees are complementary angles because they add to 90. Now, if you're given a 90-degree angle like we have here, this has got a 90-degree angle. How can you tell it's a 90-degree angle? Because it's got this little symbol in the corner. And you're given one of the angles, then you can easily find the other one. Because we know that this is a total of 90 because of this little box right here. And you're given one of them as 75, you should be able to find this mystery angle in here. And most of you are thinking, yeah, I would take 90 degrees and subtract the one that I know, that's 75. Whatever's left over has to be that missing amount, which is, in this case, 15 degrees. Again, how do you know that? It's 90 degrees minus the 75 degrees that we know. That leaves us with the remaining 15 degrees. So not overly difficult. Those are called complementary angles. Anytime you see a 90 and you're given one of the angles, you could probably find the other one. All right, let's move on. Supplementary angle. They're very similar. Supplementary angle just means that the 2 angles, maybe there'll even be 3 sometimes, but they all add up to 180 degrees. So this is a line, let's say, and this angle here is 125 degrees. Then this angle on this side must be whatever 180 minus the 125 is, and it is, it's 55. The 2 of these add up to 180 degrees, because 180 degrees goes from here all the way over to there. One giant angle. So, of course, if you're looking at the bottom one here, if you're given a supplementary angle, if you're given 180 degrees, a straight line, and one of the angles is provided for you at 75 degrees, could you find the other one? Yeah, it's going to be 180, because it's a straight line, and all straight lines are 180 degrees all the way around, minus the part that you're given, which is 75 degrees. And when you subtract 180, subtract 75, you get 105 degrees. So this angle over here has to be 105 degrees, because the 2 of these must add up to 180 degrees. Again, that's called a supplementary angle. All right, let's move on forward. We've already discussed this, but just in case you're wondering, all straight lines are considered 180 degrees of an angle. So that's one direction, that's the other direction. When you pivot go from one direction to the other, you're facing exactly 180 degrees in the opposite direction. If there was a pivot here, that angle is 180 degrees. This angle would be almost 180 degrees. It might be like 170 degrees. Because it's not quite a straight line. If it was a straight line, it would go something like that, but it doesn't. So it's close, but not quite. So all of these straight lines are considered to be 180 degrees. Anytime you have a pivot in there, it opens up to 180 degrees. So straight lines, 180. That's going to be key when we're doing some work later on. Now, here's two straight lines that crisscross. They cross each other. They cross each other at this point right here. And they create some angles that you're going to be able to figure out. First of all, these are called opposite angles because 50 has an angle right over here that is exactly opposite of the center where they intersect, and it has to create an exactly equal angle because those are the exact same two lines and they're just going in the other direction. So you're going to have the same angle here. This one has to be 50 degrees because it's exactly opposite of that one. Now I know what you're saying. I probably could figure out what this one is. How would I be able to figure out what that one is? Well, we just talked about it. This is a straight line right here. And from here all the way around to here has to be 180 degrees. So that means that this one here, the 50, plus this one here has to make the 180. And if we take 180 and subtract the 50, this one has to be 130 degrees in here. So let's erase all that. Let's go back to what we started with. This has got to be 50. And this one has to be 130. Again, you could look at it this way as well. This one plus this one has to make 180 degrees. Now, what we just talked about, opposite angles, if this one here is 130, then this one here is opposite it. It has to be identical. So therefore, it is also 130 degrees. So interestingly enough, most of you know that all the way around the circle from here to here is 360 degrees. Now, all four of these angles should add up to 360 degrees. Now, if you're given two lines that crisscross, and somebody tells you that, I don't know, this is 40 degrees, then you could figure out all of the other angles here. And you can do it quite simply because you know the rule. This one over here has to be identical. It's called an opposite angle. And then the one beside it here is a supplementary angle. The two of them, the 40 plus whatever this one is, has to add to 180 because here's a straight line. So that means that this one would have to be 140 degrees. Not 1.40 degrees, but 140 degrees. And also, obviously there, you would know that this one on the opposite side here has also got to be 140 degrees. Those are called opposite angles. And finally today, we've got parallel lines. Parallel lines are two lines that are running in the exact same direction. Anytime you see arrowheads like this on some lines that are running in the same direction, those arrowheads tell you that they are running parallel to each other in exactly the same direction, like train tracks. So here we have parallel lines, and it is dissected by this line here, which is actually called the transversal. and it is going to create some identical angles. Now, most of you already know that this angle here, let's say that we say that this angle is 70 degrees, then we could find out all of the other angles here in this set of parallel lines. We know that this one over here is opposite, so it's got to be 70 degrees. And we know the one right beside it makes a straight line. Here's the straight line. Here's one of it, and here's the supplementary one. The two of those little dots have to add up to 180. One of them is 70, so this one has to be 110. And if that one's 110, this one over here has also got to be 110 degrees because it's exactly opposite that intersection. Now, here's where parallel lines are great and easy, is that this intersection up here has to be exactly the same as this intersection down here because these lines are running parallel in the exact same direction. So because we know that the top ones are 70 and 110, we know that these bottom ones are also going to be 70 and 110 because these lines are running exactly the same direction and the same intersecting line is going between them. So we create intersections that are identical because the lines are parallel and they're running in the exact same direction. Now, if you're given one of the angles, let's put the degree sign here. If you're given one of the angles in parallel lines with an intersection, you'll be able to find the other 7 angles. So let's plunk them in. We know that the opposite angle here has got to be 66 degrees because it's exactly opposite the intersection. We also know that this one is going to be 66 degrees because all of those are going to be the same. They're the small angle in the intersection. The other ones are supplementary, so we're going to find them out. We're going to take 180 because this is a straight line right here, and this has got to be 180 degrees from here to here. 180 and subtract 66 is 114 degrees. So this angle here must be 114 degrees. The two of them have to add to 180. As soon as I know that this is 114, I also know that this is 114 degrees. And then I also know that these boys down here are 114 degrees. Now we've got all 8 of them filled in just by knowing the first one. All right, well done. So let's go through this one last time before we go. Complementary angles are 2 angles that add to 90. If you know one of them, you can figure out the other ones. Let's say that this one is 55 degrees. Then you know the other one must be, come on, what is it? What is it? What is it? Yes, 35 degrees. Supplementary angles add to 180 degrees. Again, if you know one of them, you'll be able to find the other. Let's say that this one is 120. How could you find the one beside it? Anybody? Anybody? Bueller? Bueller? Yes, 60 degrees. Opposite angles. Again, if you know one of the angles here is, I don't know, 45 degrees, then you can find out all of the other ones in the intersection. Over here is called the opposite. That's 45 degrees as well. And then this one plus this one makes a straight line from here all the way over to here. So that's 180 minus the one that you know of 45 gives you 135 degrees as this one here. And then when you know that that's 135, you know that this one is also 135. It's opposite angle. And finally, parallel lines. If you know one of the angles as 70, then you can find out all of the other angles. This one's got to be 70 because it's opposite. because they're parallel lines, these ones have to be 70 as well. And its partner must be 180 minus the 70, because this makes a straight line from here to here. So it's 110. The opposite to that is 110. This one's 110 because it's in the exact same spot. And this one's 110. So there you have it. That's all the info for today's lesson. Try the worksheet, see how it goes.